Hi everyone, it's Albert. Today let's solve the contest median question, maximum score from performing multiplication operations. And before we start, don't forget to subscribe to my channel. I'll be constantly solving good and classic LeetCode questions with clear explanation, animation, and visualization. Now let's look at the question. In this question, we are given two integer arrays, nums and multipliers, of size n and size m, respectively. We begin with a score of 0, and we want to perform exactly m operations, which is the size of multipliers. And on the ith operation, we can choose one integer x from either the start or the end, the left or the right most element from the array nums. And we will add multipliers I times x into our score, and we will remove x from the array nums. And at the end, we have to return the maximum score after performing m operations with these rules. For example 1, the optimal solution is we will always choose the end element from nums. So the first operation, we will choose 3 and then add 3 times 3, which is 9, into score. And the second operation, we will choose 2 and then add 2 times 2, which is 4, to the score. And lastly is 1 times 1. And the total score, the maximum score we can get is 14. And for example 2, for the given nums and multipliers array, the final output will be 102. And the data constraint for this question, the size of the multipliers array will go up to 10 to the power of 3. And then the size of the nums array will be bigger than m, but smaller than 10 to the power of 5. And this question is a very classic application of DFS with memoization, or you can think of it as a top-down dynamic programming. And the idea is that every step we will calculate the result of choosing either the start or end element in nums, and then we pick the maximum. And then we will DFS into the subproblems. Now let's look at the code. Okay, the code in Python is very short and concise, but there's a big gotcha here, is that here we're using LRU cache for memoization, but somehow we have to limit the caching size for some test cases in the contest. And here we will limit the caching size to a maximum of 2000. And next is to define the DFS function. And the DFS function has input of L and R pointer, and I, which is the index in the multipliers array. And the DFS function will return integer. The base condition for the DFS function is when I equals to the size of the multipliers, then we know we reach to the end. So we will just return 0. And here is a subproblem of a DFS function. And at the end, we can just return the result of the DFS call as the final output. Now let's see the code in action. Here we'll be looking at example 2. And here's the nums and multipliers array. And the left and right pointer will point to the first and last element in the nums array at the beginning. Now we will have two choices. The first choice is to pick the leftmost element from nums, multiply it to the element in multipliers, add it into score. So the next subproblem of DFS will be L move to the next element, which is L plus 1. So it will be DFS L plus 1, R, and I plus 1. Or we can choose the rightmost element in nums, multiply it, add it into score, and the next DFS subproblem will be DFS L R minus 1, which is moving R one step back, and then I plus 1. And in this case, choosing the leftmost element first will give us a bigger maximum score at the end. So now rest will become -5 times negative 10, which is 50. And following the same idea, the same process, finally, L and R will stop at negative 2 and 7, and result is 102 for this example. And this will conclude the algorithm. Finally, let's review. So the key algorithm to solve this question is DFS with memoization, or you can say it's a top-down dynamic programming. And the main idea is that every step we will calculate the result of choosing either the start or the end element in nums, and we pick the maximum of the two. And then we'll DFS into the subproblem. And time complexity of this approach, since we're using a recursion here, so with no memoization, the time complexity is big of 2 times m squared. And of course, it will be lower since we're using LRU cache in the code. And space complexity is big of m squared. That is the space needed for the call stack in the recursive function. And that will be all for today. Thanks for watching. If you like this video, please give it a like and subscribe to my channel, and I will see you in the next one.